Hi everyone, in this video we are going to introduce the concept of an ellipse. We're going to look at the parts of an ellipse and hopefully get some understanding about the difference between a horizontal ellipse and a vertical ellipse, and what's a major axis, or what are vertices or co-vertices, all the parts. So this is just going to go over the parts of an ellipse. So I am going to draw a basic ellipse. These are generic graphs. What does that mean? It means that nothing is measured. That one's not very straight. Let's see if I can get it a little straighter. Not bad. All right. And I'm going to put another one over here, another axis. Okay, now this one I am going to put a horizontal ellipse. And in this one I'm going to put a vertical ellipse. Alright, let's change colors just for fun. Okay, now this is not measured, so please don't think this is like perfection, okay? I am just making this up. So please don't make fun of my graphs, at least too much, okay? And here's my vertical ellipse. Alright. Now, yep, I didn't quite meet. Alright. Now, some people will call an ellipse an oval shape. It's basically the same type of thing. Alright, what's the difference with horizontal and vertical? Well, you notice it's longer horizontally, the horizontal. The vertical ellipse is longer vertically. Okay, the longer axis is called your major axis. So, for this one, the major axis is horizontal. Why? Because the ellipse is longer horizontally. This one has a vertical major axis. Why? Because the ellipse is longer vertically. Okay? Now, with both of these ellipses, my center is at 0, 0. Okay? We're doing that just to make this nice and easy for us. Later in the class, we will be going over ellipses that are not centered at 0, 0. But for right now, these are at 0, 0. Okay? We're going to call that origin our center. Now, a standard equation for a horizontal ellipse is this. X squared over a squared plus y squared over b squared equals 1. Okay? And the equation we're going to look at for vertical is going to be x squared over b squared plus y squared over a squared equals 1. Now, what's the difference in the two equations? Yeah, the positions of the a squared and the b squared. You notice with the horizontal, a squared is under the x squared. But with the vertical, a squared is under the y squared. And that's because a is related to your major axis. In fact, the length of the major axis is (2a). And that is for both horizontal and vertical. A is a horizontal measurement in an ellipse with a horizontal major axis. A is a vertical. You notice it's under the vertical variable, y, a squared. It's a vertical measurement in an ellipse that has a vertical major axis. So length of major axis equals 2a. So what does that mean? That means the distance from the center to this point here is a. And the distance from the center to this point here is a. So this, since it's the positive x-axis, this is positive a. And this would be negative a. The positive and the negative, remember, only have to do with direction, not value. On the vertical, this would be positive a, and this point here would be negative a. So my vertices for the horizontal let me do plural, vertices, instead of just saying vertex. Is plus or minus a, comma, 0. And the vertices for the vertical ellipse, remember a is under y, so it's going to be 0, comma, plus or minus a. Now, we have a larger axis. We know that's the major axis. Well, we also have a minor axis, and that's related to b. When my minor axis, the b, is under y squared, it is a vertical minor axis. Okay, and it's called, instead of a vertex, that distance, that would be called, that point would be called a covertex. So, covertex, or covertices, since we were doing plural, would be at 0, because it's a y-coordinate, plus or minus b. And that makes the distance of my minor axis 2b. I'm going to write that in the center because it's for both. Because this would be b, 2b. b goes from the center, so we have negative b, b, and here we have b, and we have negative b. Okay? So, for both, the length of the minor axis equals 2 times b. So if you know the length of a major axis, you can find a by taking the major axis divided by 2. And if you know the length of the minor axis, you can find b by taking the minor axis length divided by 2. Okay? And so the covertices over here are plus or minus b, comma, 0. Let me make that look a little more like a 0. Okay. All right. Now, another thing we need to go over are the foci. See, an ellipse has 2 focal points. Okay? They are fixed points where, well, it's kind of neat if you took and put, like, had 2 fixed points, and then we're just gonna, just for purpose here, this is C, and this will be negative C. So our focus or since we're going to do plural, foci are, for the horizontal, plus or minus C, comma, 0. And for the vertical, are 0, comma, plus or minus C. Now, you notice in the vertical ellipse, A is a y coordinate, so C will be a y coordinate because it's always on the major axis. A was an x coordinate for the horizontal ellipse, so that means that C is an x coordinate on the horizontal ellipse. And let me put my foci here. This would be C, and this would be negative C. Okay, now the foci are two fixed points in an ellipse. Okay, it's kind of neat though. If you actually had like two things like tacks or something, you could take a piece of string and tie it and make it, tie it together circularly. And you could pull a pencil around it. If you pull it tightly, you could actually use it to draw an ellipse because the string will go against each of the two focal points and you will get this nice oval shape. It's kind of a cool way to draw an ellipse. Now, I believe, I know one thing we need to go over. To find a focus, if you know like both A and B, to find C, C squared will equal A squared minus B squared. Okay, this will give you your position for C, the length of C. All right, now this is not the Pythagorean theorem. Because remember Pythagorean theorem, there is a plus here. It's related to it, but it is not the Pythagorean theorem, so please don't confuse them. And the reason for this is, you notice, what distance is the largest of these? Well, A is the largest, so A has to be doing the subtracting. I could solve this for A and say that A squared is equal to C squared plus B squared by adding B squared to both sides, but that might be a little confusing for some people, and they might mix it up with their Pythagorean theorem. Just remember, C is focus, the coordinates of a foci. All right, and there we have it, our introduction to ellipses. I know it's quite a long video, but this is like so packed with information. All of the stuff here is really all you need to do all of the problems that we have in this section of our textbook. Have fun, enjoy them, and we'll be talking about them in class.